All right, so if I recall last time, we started off with the identities, right? We saw the Pythagorean identity, one of them. All right, there's two others, but if you know that first one, so this is just 1.4, that's kind of continued. We'll wrap this up pretty quickly. Now we saw that the sine squared of some angle plus the cosine squared of some angle, that's equal to 1, right? That one's pretty easy to remember. It's like in algebra, you remember y equals mx plus b. Everybody remembers that. That just rolls off the tongue really easily, right? The same thing with this one. This is one of the most common trig identities most people can remember. Sine squared plus cosine squared is 1. It's the other two that come off of this one. That's kind of get a little mixed up sometimes. Okay. But it's really easy to derive it. It doesn't take but a couple of seconds to do that if you wanted to. Okay. So this is an identity, a known fact. Now, if I take an equation, I can add, subtract, multiply, divide by a number. As long as I do it to one side, I do it to the other side, right? So I'm going to do that. I'm going to divide everything by a number. Sine squared is a number, right? You can type that in the calculator and see sine squared of any angle, right? And get a number out. And sine squared is being divided by everything. I almost said cosine. So from here, we can simplify these. Sine squared over sine squared, same number divided by same number is 1. Now, I haven't told you this yet, but this is another identity right here. Cosine over sine. It's called a quotient identity. It's a quotient of two trig functions, right? That is equal to cotangent of theta. It's cosine over sine, but this is all squared, so it's going to be cotangent squared. And 1 over sine, you know that one, that's a reciprocal identity, right? That is equal to cosecant. So that's 1 over sine times another 1 over sine, right? So that's cosecant squared. So here is the other Pythagorean identity derived from the first one, just by dividing by sine squared. Take that same equation, sine squared theta plus cosine squared theta equals 1. Now let's divide it by the other trig function in there, cosine squared. Well, we saw in this last one, cosine over sine is cotangent, so the flip of cotangent is tangent, right? So that means sine squared over cosine squared is tangent squared. And cosine over cosine, same thing over same thing. It's 1. And the reciprocal of cosine, 1 divided by cosine is its secant, that's squared. So that's the third Pythagorean identity. So again, if you don't really commit these to memory, say you want to use that memory space with something else, you can always come back and derive them if you need to. But it's a good idea to know those, because when we're going to get to another section, establishing identities, if you have this big, god awful mess, and you see a tangent squared in there, maybe a secant squared in there, that should give you a hint. Okay, maybe one of these identities, since both of those are in there together, can be used. Okay, if you see a 1 plus or a 1 minus something in there, Pythagorean identity is typically used somewhere in there. All right, so the next identities are the quotient identities. We've already just talked about those. Probably should have did this one first. The sine of an angle divided by the cosine of an angle. So that is the tangent of that angle. we're going to start figuring out these special trig function values of special angles. I don't know my tangent values, but I didn't put those committed to memory, but I did commit sine and cosine. I can just take those two numbers and divide them and get a tangent. Or I could flip it around, cosine over sine, just the reciprocal of this over here, so that's going to be a cotangent. So that's your quotient identities. So we had the reciprocal identities, the Pythagorean identities, and the quotient identities. All right, so you can also use identities to figure out other trig function values. Okay, suppose you have, say, given the cosine of some angle theta is equal to the square root of 3 over 4. And let's say the sine is positive. Okay, so if I know the sine is positive, cosine is positive, where are we? What quadrant? Everything's positive, so quadrant 1, right? My handwriting's bad. Let's see. So we know quadrant 1. All right, I can say it's known that sine squared theta plus cosine squared theta equals 1. You're given cosine, I can solve for sine, right? So the value of cosine is square root of 3 over 4. In this formula equation, it says square it. So that leaves sine squared theta plus the square root of 3 gets squared, which is 3. The 4 in the denominator gets squared is 16. It's equal to 1. Subtract off 3/16. So 1 minus 3/16, that's 16/16, minus 3/16. Sine squared of theta is equal to 13/16. That's sine squared, right? So I need to get rid of the square to solve just for sine. Sine of theta is technically the plus or the minus of the square root of 13/16, right? But we already said we want sine to be positive. So we throw away the negative. And we simplify that down a little bit. So the sine of theta, using these identities, is found to be the square root of 13 over the square root of the 16, which is 4. What if I ask you, what is the tangent of theta? Well, I can go back and use one of those identities, but it wasn't given a whole lot of information with tangent, with cosine. That's the given information, right? Or one with tangent and sine that we just found. But I do know that this is equal to the sine of theta over the cosine of theta. We just found the sine of theta. Square root of 13, of course. And the cosine of theta was given square root of 3 over 4. Which that equals 13, square root of 13 fourths times the reciprocal of the bottom, 4 over the square root of 3. Fours cancel. Leaving square root of 13 over the square root of 3, and let's rationalize it. So two square roots multiply to each other. I can multiply the 13 and the 3 and make it as 1 square root of 39. And square root of 3 times square root of 3 is 3. So now I just found the tangent just given one bit of information. So that's an alternative way to find all trig function values. It's by using identities. Now I won't be specific and say use an identity to find these trig function values, because you can always go back to the top of what's given. Cosine, that's x over r, right? And then we can find y, and then we can figure out all our other trig function values just with those relationships of x, y's, and r's. Right? So sometimes identity is really nice and easy and quick to figure it out, missing one trig function. But if you need to figure out all of them, probably x, y, and r will be your best bet. All right, so that is 1.4. Any questions? Scroll down. Oh, yes. Oops. What's that?